Okay, this is 4.6 Taking Sides. Joaquin and Serena work together productively in their math class. They both contribute their thinking, and when they disagree, they both give their reasons and decide together who is right. In their math class right now, they are working on inequalities. Recently, they had a discussion that went something like this. Joaquin says that 6 less than a number is greater than 4. I think we should just follow the words. 6 minus n is greater than 4. Serena said, I don't think that works because if n is 20 and you do 6 less than that, you get 14. I think we should write it n minus 6 is greater than 4. Joaquin says, oh, you're right. And then it makes sense that the solution would be n is greater than 10, which means we can choose any number greater than 10. So there are several other conversations between Joaquin and Serena on this paper. So the very first one says the inequality to the graph is x is greater than or equal to negative 7. Joaquin thinks that the graph should have an open dot at negative 7. Serena thinks that the graph should have a closed dot at negative 7. So on a number line, when we graph inequalities that just have one variable, whenever it is or equal to that line under the inequality, it is a closed dot. So when it's less than or greater than, it's open, less than or equal to or greater than or equal to is closed, which means that Serena is correct. Because the or equal to means closed dot. So on the next one, we have the problem is 3x plus 1 is greater than 0. Serena says the problem is always true because multiplying a number by 3 and then adding 1 to it makes it greater than 0. And it says, is she right? Explain why or why not. So what you should do in each of these situations is plug in some numbers and see if they work. So if I plugged in a 2, I would have 3 multiplied by 2 plus 1 is greater than 0. 3 multiplied by 2 is 6. 6 plus 1 is 7. 7 is greater than 0. True. So if I plug in another number, like 0, on one of our last assignments we had, well, what about 0 on several problems, and it made a different answer. So we can try that. 3 multiplied by 0 plus 1. So 3 multiplied by 0 is 0, plus 1 makes 1, which is greater than 0. So this is also true. So what if we plug in a negative number? So I'm going to put 3 multiplied by negative 2 plus 1 is greater than 0. So 3 multiplied by negative 2 is negative 6. Negative 6 plus 1 is negative 5, which gives us a false statement. So Serena's correct if we're talking about numbers 0 and larger, but when we get into the negative numbers, she is not correct. So if x equals a negative number, Serena is incorrect. So she is not correct if x is a negative number. So then we move on to the next one. It says the word problem is 4 greater than x. So this kind of goes back to that example problem where they had 6 less than a number. So when we have 4 greater than x, that actually represents addition. So Joaquin says they should write it as 4 is greater than x. So when we have the inequality, it reads 4 is greater than x. Without that word is, it simply means addition. So like having $4 more than somebody, being 4 inches greater than your peer or your friend. It means that you are 4 more than, which is addition. So Serena is correct. So this next one is actually at the top of the back of this paper. Mine printed on the front for some reason and yours printed on the back. So we have, Joaquin has this amazing idea about inequalities and equations. If 45 plus 47 equals t, then t equals 45 plus 47. So the easiest place to start with this is to simplify the statement. So 45 plus 47 is 92. So I'm going to change this to if 92 equals t, then t equals 45 plus 47, 92, which is true. So we have to decide, is the same thing true with inequalities? Can we just switch which side the t is on and it be true? So we need to simplify this as well. So we have 45 plus 47 is 92 is less than t, then t is less than 45 plus 47, 92. So this one says t, is greater because it's on that end of your inequality. Whereas this other one says t is less than because it's on that side of your inequality. So this is false. So he's not correct to make that assumption that you can treat equations like inequalities. So continuing on, Serena got to think about what Joaquin said in number 4 and thought about the similarities and differences. Serena wonders about the equation negative x divided by 3 equals 4 and the inequality negative x divided by 3 is greater than 4. So when we solve these, the easiest way to assess these is to actually solve them yourself. So we have negative x divided by 3 equals 4, and negative x divided by 3 is greater than 4. So the very first thing we need to do is on the equation, the very first step is to multiply by 3 because we have to get that 3 off the denominator. And we're left with negative x equals 12. The first step on the inequality is also to multiply by 3 because we have to get it out of the denominator. So we're left with negative x is greater than 12. So far, something they have in common is the first step. So down where it asks, what are the similarities in solving these two? I want to say step 1, multiply by 3. So now when we go back to the equation and we look at the second step, the x has an implied coefficient negative 1. So we have to divide by negative 1 on both sides of the equation in order to get the solution. X equals negative 12. Looking at the inequality, we have to do the same thing. There's that negative 1 in front of the x, that coefficient negative 1. So we divide by it, and we get x. And because we divided by a negative, remember, you must flip the sign when you divide by a negative. So it becomes less than negative 12. So for step 2, On both equations, we divided by the -1, so that's something they have in common. But something that's different is on the equation, there's nothing you have to flip around. For the inequality, you do have to flip the inequality symbol when you multiply or divide by a negative. So that's something different that you have to do for the inequality. So in an inequality, when you multiply or divide by a negative, you must flip the inequality symbol. Moving right along. Joaquin solved -15q is less than or equal to 135 by adding 15 to both sides. Serena said that was wrong. Who is correct and why? Well, because this -15 is a coefficient for q, you cannot add it to both sides. So Serena is correct in saying that there's an error. What they should have done is divide by the 15. So should have divided by the coefficient -15. So then Joaquin's solution was q is less than or equal to 150. He checked his work by substituting 150 in for q in the original equation. So the original equation is this one. So does that prove that Joaquin is right? So if we do the same thing, if we take the original equation and we plug in 150 for q, just as Joaquin did, we have to see if it equals less than 135. So when you multiply -15 multiplied by 150, you get -2025, which is less than 135. So this is true. So Joaquin is still skeptical, and he believes he's right. Find a number that satisfies his solution but does not satisfy the original inequality. So looking at the inequality, if we plugged in a 0, -15 multiplied by 0 is 0, which is still less than 135. So 150 worked, 0 works, so we need to try some other numbers. So when teaching this in the classroom, I had somebody actually offer up that negative numbers would produce numbers larger than 135. So we used the value 10. So we said, what if q is -10? So if we plug that into the original equation, we have -15 multiplied by q is -10 should be less than or equal to 135, unless it's not a solution. So -15 multiplied by -10 is +150. So our statement says 150 is less than or equal to 135. That is false. Now, the reason I chose -10 and the reason my students have always chosen -10 is because -10 fits Joaquin's solution, that q is less than or equal to 150. So we had to try numbers that were less than 150 to see which one created a false statement, and that negative 10 is kind of just where we ended up. All right, Serena is checking her work with Joaquin and finds that they disagree. Here's what Serena wrote. So this is what Serena wrote. So the easiest way to do these error analysis is to actually work it out yourself. So the very first thing I see is she had a 3x plus 3, and it became just a 3x on that side, which means she had to get rid of the 3. To get rid of that positive 3, we subtract it. 5 minus 3 is 2. They've done this correct. So then if we look at the next step, we need to move this negative 2x to the left side, because you cannot combine the like terms if they're not on the same side of your equation or inequality. So to move that negative 2x, we have to do the opposite, which is addition. And that's where the error occurs. This is not accurate. So what they should have had is 5x is less than or equal to 2. So when you divide by 5 on both sides, you can either leave it as a fraction with 2/5, or you can say x is less than or equal to 0.4. They are the same thing. So Serena was incorrect here because she combined like terms when they were on different sides of the inequality. So I need to write Serena is incorrect. And we already fixed it as we went through each of the steps. So the next one says they are having problems solving the following inequality. Show them how to do it correctly and list out all the properties you use. So the first thing we need to do is we need to distribute. We need to get rid of our parentheses through distribution. So we have negative 12m plus 4 greater than or equal to 2m plus 6. And again, that's the distributive property. So then next, I want to get all the m's on one side of the equation. So I'm going to move them to the left. So I'm going to subtract the 2m from both sides. And I'm left with negative 14m plus 4 is greater than or equal to 6. Then when I subtract 2m on both sides, that is the subtraction property of equality. And in previous lessons, we shortened property of equality to POE. So you can also put POE for all of these for property of equality. So then the next thing we have to do is we have to get the 4 to the right. So we subtract 4 on both sides, which is your subtraction property of equality. And we end up with negative 14m is greater than or equal to 2. So the last thing we need to do is divide by negative 14 on both sides, which is your division property of equality. And that will give us our solution, where m, and remember guys, when you multiply or divide by a negative, you must flip your inequality sign. So m is less than or equal to negative 1/7. So for the next ones, for each of these, we are finding the solution and telling what they are, and then describing how we would graph it on a number line. So this first one, we want to get all of our s's on the same side, this crosses out, this crosses out, and we end up with 6 is greater than or equal to 6. Because that is a true statement, the answer to this is infinite solutions, or all real numbers. So on the second one, when we subtract 3r from both sides to get all of our variables on one side of the inequality, we end up with 5 is greater than negative 2. Because that's a false statement, it's no solution. Last one in this grouping. So the very first thing we need to do is distribute the 4. So we have 4n plus 4 is less than 4n minus 3. So when we subtract the 4n off both sides, they cross out and we're left with 4 is less than negative 3, which is false. So it is no solution. Now, I forgot to describe how they look on a graph. No solution, you actually do nothing on a number line because there is no solution to it. When it is all real numbers or infinite solutions, on a number line, you would actually highlight the entire line. So it would be a line that goes in both directions with arrows on both ends because it includes all of the numbers in that set of solutions. All right, last problem. The partners are given a literal inequality. Ax plus b is greater than c to solve for x. Joaquin says it'll solve just like an equation. Serena says they need to be careful because if a is a negative number, then the solution will be different. What do you believe? Solve it. So the first thing we need to do is actually solve this. And we have ax plus b is greater than c. So in order to get x by itself, the very first thing we have to do is subtract b from both sides, which leaves us with ax is greater than c minus b. So when we divide by a on both sides of the inequality, we're left with x is greater than c minus b divided by a. Remember, with literal equations, you cannot you're not going to get one answer. Sometimes you can simplify parts of it. Most of the time you cannot. So if a were to be negative, we need to put this off to the side. If a were positive, this is how it would look. So I'm going to put I should put if a is positive. But if a was negative, if we were dividing by a negative on both sides, the only thing that would change is that we would be dividing by a negative a. So if a is negative, you would have to flip your inequality symbol. And typically you don't see a negative in the denominator of a fraction, but if you guys put a negative in the denominator at this point, I would not count it incorrect. But normally, you distribute the negative to both of the numerator values. So we have x equals negative c plus b over A. So again, all I was doing was giving that negative to each of the values in the top of the fraction in order to get the negative out of the denominator. So yes, there is a difference. Serena's correct. Joaquin is correct. If we solve it like a regular equation where A is positive, the inequality would not flip. But if that A value ended up being negative, you would have to flip it in the end.